a pleasant morning, and our chosen article is some special properties of fermented products with cabbage origin, pickled cabbage, sauerkraut, and kimchi, which was published in Food and Science and Technology last 2019, authored by different scientists. But before we will start, let me introduce my groupmates.
I'm Anie Calayag. And I'm Judy and Palcotan.
And I'm Jhenny, antawag.
And yours truly, Mariah, Gypsy, Laviña. Many researchers have been focused on traditional fermented products worldwide. Lactic acid, LA fermentation of traditional fermented cabbage products including kimchi, sauerkraut, Chinese sauerkraut, pao kai, and pickled cabbage is spontaneously developed by lactic acid bacteria present in raw materials under anaerobic condition. PC or pickled cabbage, SK sauerkraut, and KM for kimchi are important sources of minerals such as calcium, phosphorus, iron, sodium, potassium. These fermented products have also high contents of vitamin B and C than fermented cabbage. PC are traditionally prepared by brine and vinegar solution with carrot, garlic, and chickpea. While brine concentration is chosen as suitable for growth of lab, thereby mainly natural lab present in raw materials perform LA fermentation. In addition, new compounds are obtained by metabolism of lab during natural fermentation. Moreover, PC has a good taste and aroma as well as richness of nutrients. Sauerkraut is one of the most common fermented product produced by fermentation technique which is widely consumed in many European countries, Central and Western Europe, and USA. Sauerkraut could be stored for long periods even though its low salt content. Spices, herb, carrot, and wine are also used in manufacture of sauerkraut. Growth of spoilage microorganism is inhibited since lab produce acids during fermentation in a short time. Kimchi is the most popular traditional Korean fermented food made from many vegetables such as cabbage, radish, green onion, ginger, various spices, seasoning, and fermented fish products. Fresh vegetables are prepared traditionally to preserve and enhance the organoleptic and nutritional qualities.
Materials and methods. Concerning production of pickled cabbage, 2 kg were divided into 4 parts of placed in 3-liter plastic bottles. After addition of sterile 8% brine solution, grape vinegar 2% and sugar 2% were added. Fermentation were carried out at 25 to 28 degrees Celsius for 30 to 40 days. Next, sauerkraut. Regarding production of sauerkraut, the fresh cabbage 3 kg were shredded into approximately 2 mm thick strips. The spontaneous fermentation of sauerkraut was carried out with 3% salt concentration and 2% sugar at 21 degrees Celsius for 30 days. So for kimchi, during the preparation of kimchi, Chinese cabbage were cut into pieces 5 by 5 cm, dissolved into brine solution containing 10% sodium chloride for 7 to 8 hours. The soaked Chinese cabbage were washed 3 times for removal of residual salt and drained 1 hour at room temperature. After draining the sliced Chinese cabbage, 75% were mixed with various seasonings including red pepper powder 2.2%, minced garlic 0.85%, sliced daikon radish 7.5%, ginger 0.85%, green onion 2.0%, onion 1.1%, fermented fish sauce 0.5%, apple 2%, wet floor tap water porridge 8%. The salting mixture was then tightly packed into 3-liter plastic bottles and allowed to fermentation at 47 degrees Celsius for 33 days. So here are the picture of kimchi.
Sampling of materials for analysis. During the fermentations, cabbage samples were aseptically collected at intervals of 3 days from the day 0 to observe development of acidity and pH. In addition, sample 10 grams were taken to determine salt content. Sodium chlorides once a week throughout fermentation. Next, determination of total acidity and pH. Here is the formula of total acidity and pH. So, acidity is the total of fermented products was determined by titration method with the standard of solution of 0.1 nitrogen, like sodium hydroxide. So, grams over 100 ml equals to, where V is the amount of 0.1 nitrogen, sodium hydroxide solution use of ml. F is the factor of 0.1 nitrogen, sodium hydroxide solution. And E is the constant of lactic acid, equivalent to 1 ml to 0.1 nitrogen sodium hydroxide. Then 100 equivalent to solution of 0.009008, and over M is the amount of sample used. Next is determination of salt, sodium chloride content. The formula. X is the concentrations of sodium chloride percent. Next, V is the volume, ml, times F is the factor of standardized times 0.005844 by silver nitroxide times EF is called dilution factor times 100. So, next is the dilution factor equal to volume 1 over M, sample use times 1 over volume 2. Next, dry matter determination. Dry matter content was determined by drying at 105 degrees Celsius to constant weight, commemorate Universal Oven, Universal 55, Germany. Dry matter of fermented cabbage product, pickled cabbage, sauerkraut, and kimchi, was determined according to Summerglow 2007. So, the different cabbage samples were cut into small pieces, and the cabbage tissue were subjected to drying process of 105 degrees Celsius in 24-hour and atmospheric pressure. So, next, determination of ascorbic acid, vitamin C content. Ascorbic acid was determined by a spectrophotometry method, genesis of 10S UV VES spectrometer, thermoscientific, taking observance at 518 according to method described by Hissel, 2/6 diclophenol endophenol dye was reduced by ascorbic acid, which was reduced to the colorless. Next, determination of total phenol content. Total phenol content of the fermented products was determined by by a spectrometric method according to Fullin's Kiokelty procedure. 1 gram of samples were weighed into Falcon tube prior to addition of 10 ml 80% methanol solution. Methanol dionyzed water, volume per volume. Samples were extracted with 80% methanol by homogenizer. So the sample extract were then carrying out by shaking incubator at room temperature for 16 to 18 hours and filtered with filtered paper. So next is determination of antioxidant activity by DPPH free radicals scavenging assay. DPPH radical scavenging active was performed with some modification according to the method described by Simiroglu 2007. So DPPH percent were equals to A0 minus A1. So A0 and A1 were absorbent values of blank and samples as struck. Then times 100. Last is statistical analysis. The statistical analysis was evaluated with the SPPSS code IBM USA software program version 23 for Windows. The one-way analysis of variance ANOVA was used to determine the significance among parameters. Duncan's multiple range test was used as post hoc test. Confidence interval was chosen as 95%. So the next slide will be presented by Anie.
Result and discussion. Total acidity, pH, and sodium chloride changes. The pH, acidity, and salt content are the primary quality attributes and fermentation indicators of fermented products. Changes in the titratable acidities, pH values, and salt concentration of PC or pickled cabbage, sauerkraut, and kimchi during their incubation at 25 to 28 degrees Celsius of pickled cabbage, 21 degrees Celsius of sauerkraut, and 47 degrees Celsius of kimchi between 30 to 40 days. So based on the graph, acidity of sauerkraut initiated is faster than the PC and the kimchi. So at the end of this fermentation, the highest table acidities were determined for sauerkraut 1.09%, pH 4.15, while kimchi is 0.99% and the pH is 4.29. So however, the acidity of PC or pickled cabbage were very slow until it came 24D, 0.43%, and the pH is 4.05. So after which acidity remained stable, these results demonstrated that the LA or lactic acid fermentation is have a low salt products decrease or increase than high salt products. So in this graph, PC has the highest, sauerkraut has the highest percent, next is the kimchi, and the last is the pickled cabbage. So next is the pH. The highest is the kimchi, next the pickled cabbage, and the last we have sauerkraut.
So here the sample of my house for analysis.
The last graph is we have the highest percent PC or pickled cabbage. The next is sauerkraut, and the last we have kimchi. So figure 1 changes in tetra table activity A, pH, B, and salt concentration C of cabbage-derived products during the presentation period. So this is the legend. So triangle means pickled cabbage, circle means sauerkraut, and the square shaded means kimchi. So these data were presented as means standard deviation. N is the number of fermented fermented. So next is ascorbic acid, vitamin C content. So white cabbage 36.6 milligram or 100 gram, and Chinese cabbage 27 milligram or 100 gram contain high amount of vitamin C according to USDA or United States Department of Agriculture food composition databases. So in this graph, it is clear that pickled cabbage contain the most vitamin C, followed by sauerkraut, and the last is the kimchi. Although it is known that fermented cabbage have the highest content vitamins, there are limited studies regarding vitamin C production by kimchi, sauerkraut, and the pickled cabbage. Next is the total phenol content. So, the impact of fermentation on bioactive compounds, if phenols was also evaluated. Among the fermented cabbage products, kimchi exhibited the highest total phenol content of 869.64 plus minus 70.16 milligram over 100 grams. And it is followed by the sauerkraut, and the next is the pickled cabbage. So, total phenol content of kimchi has the total of 869.64 milligram over 100 gram, was higher than that of sauerkraut, 438.26 milligram over 100 gram by the 2 times. So the kimchi has the highest percent, or has the highest milligram over the PC, and it caused by the 2 times of their milligrams. So, based on that graph, results of the TPC or total phenol content considerable variable depending on the sample ingredients, fermentation process, and sample extraction with water, methanol, and ethanol composing large molecules into small phenolics. The total phenol data in the present study and literature exhibit a great difference in the results given by the various authors. So next is antioxidant activity. The PPH radical scavenging assay were conducted to evaluate the antioxidant capacities of 3 different types of fermented cabbage products, where the 3 fermented products are pickled cabbage, kimchi, and the sauerkraut. So, EC50 values of the 80% ethanol extracts of kimchi, sauerkraut, and PC showed high DPPC. It is reported that The antioxidant activities of cabbage could vary among the different process and fermenting conditions.
And for the conclusion, this study provided an overview of the three types of cabbage origin fermented products and evaluated an antioxidant activities of sauerkraut, kimchi, and pickled cabbage at different fermentation parameters. The result indicated that these fermented products may be assumed as dietary foods processing high antioxidant activities, demonstrating the presence of valuable bioactive compounds with high functionalities as fermented foods. Future prospect: spontaneous fermentation of natural traditional products provided a factinous lab present in the surface of the raw materials. Additionally, these traditional products are excellent sources of starter microorganisms to be used during controlling of fermentation process and consistency of end product to improve safety and quality of traditional fermented products, to characterize functional starters, and to tolerate gastric intestinal conditions.